Okay, so up to the next part of arrangements, and this time we've got arrangements where the order is not important. Okay, so the order is not important. When we had permutations, the order is important. Okay, so let's remind ourselves about that. So permutations, order is important. This time order is not important. Okay. And the typical questions are Lotto games, like Saturday night lottos, and committee questions. So that's what we'll be focusing on. Okay, turn on, come on. Okay, so notation for combinations. There's another button, depending on your Casio, could be the button underneath NPR, or could be a button above the times or divide. So it just depends on your calculator. So you're looking for NCR on your calculator, and it means R selections from N things. And using the factorial idea again, there's a different formula. So when we had NPR, that was just N factorial over N minus R factorial. Now we've got this extra term R factorial, because there's going to be less arrangements where the order's not important, so we'd have to divide to get a smaller number. Okay, so you need to know what the origin of that is. Okay, so typical question. So we'll have a look at Lotto on Saturday Night Lotto. Again, I'm not too sure if there's 42 or 45 numbers, but let's just say there's 42. So in how many ways can you pick 6 numbers in Lotto if there are 42 numbers to choose from? So 6 from 42 is 42C6. So using the factorial approach, it's 42 factorial over 36, and I would accept that answer in a test, but if you use your calculator, you get 5.2 million different games. Okay, so that's why only 1 or 2 people pick it, because there's so many different ways to pick 6 numbers from 42. Okay, copy and then come across when you're ready. Okay, so I'm going to talk about system entries, because that's what happens often. People get together, or you might have 7 lucky numbers, so you can play a system entry. And what the computer does at the newsagent is actually just groups all the numbers together in groups of 6. So if you have system 8 entry, you get to pick 8 numbers, but you're still getting arranged in groups of 6. Okay, so the number of games that you play for system 8 is 8C6. You've got 6 numbers to get chosen from 8, so there's 28 different arrangements of 8 numbers into groups of 6, and so you would pay 28 games. So if each of these games is 25 cents, you multiply 25 cents and then you get your total cost. Okay, you're not getting a discount. It's just the computer's working out a short way for you to get your games played. And so your probability of winning is you've got 28 games where you're going to win, but there's 5.2 million games. So the chance of you winning is a really small fraction or decimal. And again, someone's going to win. Okay, and every week someone wins, so play if you want to, but your likelihood is you're not. Again, I'm not sure what the biggest entry is at the newsagent, but you could have a look next time you go to a newsagent, whether it's system 12 or system 14 or whatever. But if you have a system 12 entry, it's 924 games, and a system 14 entry is 3,000 games, and that's when people get together and chip in, 30 or 40 bucks each and get more games. You're not getting a discount, it's just you're getting more games than you pay for them. Okay. All right, so looking next page. Okay, so here's the typical committee questions, and I'm just going to pause. I want to calibrate the pen. The pen's a bit dodgy. Okay, so we're back on. I just had to calibrate the pen. Okay, so here's a really typical question about people on committees. And I've made it I get each part is a bit more complex. So we've got 5 men and 4 women applying to be on a committee of 4 people. Okay, so we've got different numbers, and the committee's got 4 people. So we'll build up the complexity. So the first one is how many different committees are possible with no restrictions. So in the first one, we've got 9 people, and we have to pick 4 from them. So the answer would just be 9 factorial over 5 factorial, 4 factorial. I'm just going to pause and get my calculator. I've left it behind. So it probably felt like I was away forever, but I was just getting my calculator, and the answer is 126. Okay, so the next question, there must be 2 men and there must be 2 women. And again, just to remind ourselves, because they're getting a bit higher, I have 5 men and I've got 4 women. Okay, so that's how many people. So in part B, okay, there must be 2 men and there must be 2 women. So that means for the men's selection, I want 5C2. I have to pick 2 from 5. And for the women's selection, I got 4C2. So I'll just put that on the calculator. So there's our 4 people, 2 men and 2 women, from 5 and from 4. Okay, so 5C2 times 4C2. And so there are 60 different committees. Okay, so the answer must be less because this is the unrestricted case. So the answer can't be bigger than 126. So we've got different selections from the 126. Okay, oh, gone too high again. Part C, okay, there must be at least 1 woman. Okay, so there's a 1-woman committee, there's a 2-woman committee, there's a 3-woman committee, and there's a 4-woman committee. Okay, that's a majority, at least 1. So the only one that you don't want is no women. So the answer is, rather than doing 1, 2, 3, and 4 and then adding answers, the only answer that isn't right is the no women. So we're going to subtract. When I say 1, that's a probability. So it's their unrestricted case there. Okay, so no women must be 4 men. And the 4 men would be 5C4. And I'm pretty sure that's 5. So 5C4 equals 5. So therefore, at least 1 woman would be the unrestricted case, minus 5 equals there's 121. So there's 121 different ways. But again, you could do 1, 2, 3, 4 and add them up and you get 121. Okay, in part D, there's 2-woman, 2-man committee, and 1 particular man and 1 particular woman must be on the committee. Okay, so in D, 1 man, 1 woman must be on. Therefore, you only need 1 more man, only needed. Now, to pick 1 man, you don't have 5 left because this guy has already been put on. There's only 4 left, and you need 1 guy from 4, and that's going to be that answer's 4. And because 1 woman has already been put on, there's only 3 women left. I'll just rub that out. There's only 3 women left, and you need 1 woman. So that's 3. And so to have 1 particular man and 1 particular woman on, these answers are multiplied. Okay. So there are 12 committees. So 1 man and 1 woman must be on. So there's 12 committees that are left over. And in part D, okay, they cannot be on the committee together. Okay, those same 2 people, whatever, cannot be on the committee. So in this particular case, what we do is when we want them not on, we actually put them on. And then subtract from unrestricted. So therefore, them not being on equals 126 minus 12 equals 114. So there's 114 ways for that 1 man and 1 woman not to be on together. And I think that's it. So from the worksheet, the electronic textbook or the worksheets, there's exercises to do. Okay, thanks, bye.